Take 2 more minutes to make sure you have something in at least every box. Thank you to my friends who have their pencils down, eyes up here. All right, at this point, please direct your eyes to Mr. Kenny. He is going to ask a few of you to volunteer as I capture it up here on our large cup KWI for us. Please remember that as we are adding ideas up here, if you do not have them on your page, you need to add them to your own KWI, okay?
All right, so the first thing we need to think about is what do we know about this problem? What is this problem giving us that we can work with? Dante, what does it give us?
That she or he is going to his grandma's house for a birthday.
Okay. I love the silent I agree statements I'm getting from a couple students as they listen to their peers. Maya, do you have something?
There is one troll for every bridge.
One troll for every bridge. All right, is there anything else we can think about in terms of no? Maya.
He has to arrive at the house with exactly 2 cakes.
Nice. Have to have exactly 2 cakes at the end. So that's something you definitely have to think about as we process through this. All right, moving on to our W. What do we need to find out? What do we wonder about this problem? We need to find out and wonder. Amir?
I wonder if you can cut the cake in a certain half. To seem like there's a certain amount of cake that the trolls take, like cut the cake in half already, then just they're gonna take this one for.
Nice. Try to like cheat the troll or trick them. Let's move on to the last part. What ideas or strategies can we use to solve this problem? What can we do to help ourselves figure this out? Hebrew? Using multiplication, sure. Alright. What else are on the list?
You can use labels,
Use labels? What are you going to be labeling?
a picture.
Okay. So create a picture of what's happening and make sure you're labeling so people can see what's what. Nice. Jeremiah? School materials. Can you give us a few examples that you could use that might help us out in solving this?
Scissors.
Scissors. Okay. Anything else, David?
Might not sound correct, but actual cake.
Actual cake. Well, I'm gonna let you know I'm not giving you actual cake, but nice.
But David, is there something in this room that you could use to represent the cake?
Asians.
Okay, so you might create a physical model of the cake.
Sure. But like, think about how we've used Unix cubes in the past to represent numbers.
All right, so at this point, a few reminders before we get started. You may choose to work with someone else in this room. Please remember that when we choose partners, we are choosing someone that will lead us to be successful. Okay? You have access to anything that you see out in this room. If you can think of something that you need that you don't see, you are welcome to ask us. At this point, you guys may get started finding a comfortable spot in the room and someone to work with. Go.
That's one bridge.
So if I were solving this problem, I think I would probably write it out each bridge. So like at the first bridge, he might have this. At the second bridge, he might have this. At the third bridge, he might have this. And then try to figure out, okay, if he has 2 at the end, how can I work backwards? Does that make sense? All right, I want the 2 of you to talk about that, okay? Remember, he has 2 at the end.
She has 2 and 1 half. Yes. Now she has 2 and 1 half each. And now we gotta draw another troll and keep on going until we have the amount she had.
What is it that you did here that needs to be part of your equation?
I did
Blocks. Yeah.
2 minus 1.
plus 1, and I did it 7 times.
Okay, so that 2 minus 1 plus 1 is the key that you're missing. Because that is what you have to do every
Okay.
single time,
Yeah.
no matter if there's 7 bridges or 7,000 bridges. Okay, so that is the part of the equation that you need to think about.
But then I'm a nice troll, so I give you 1. How much do you have?
3.
3. Now we go to the last bridge, the last troll.
What about 5?
Why are you changing the number? You saw that you wouldn't get 2?
Yeah.
All right, change it up.
First bridge.
So, first bridge, you have 5?
6.
6. Why'd you change it?
Because I can't give him half.
All right, what happens?
Here.
You give me half as the toll, but then I'm a nice troll, so I give you 1. But now you're at 4. See? I love it. You're seeing the answer before we get to the end.
All right, ladies and gentlemen, I appreciate your efficient cleanup. As Mr. Kenny and I were walking around, we saw a lot of variety in the strategies that you guys chose to use to solve this problem today. Raise a silent hand if you would like to share with us not an answer that you got, but a strategy that you tried. Carlos, what were you guys trying?
What we tried is we tried to use like set of blocks, and we went to every troll and gave them half of our blocks every time.
So what was the strategy that you used?
The strategy that we use is we basically got like a cake, and then we split it in half. And every time we split it in half, we give them the troll a cake, and the troll give us one whole cake back, and then we move on to the next troll.
So you created a physical model using Unity.
Yes.
What were some roadblocks that you hit as you were trying to solve it, Victor?
When we were at the troll, when we were getting to the troll, and we had to give them one cake, and then they would give us a whole cake. So that was a sort of trick. Difficult.
Okay.
When we were getting that.
Okay. Sky?
When we were doing it, like we didn't know that we had to give the troll half of what we had, like everything that we had. We thought that we just had to give them half of the cake, so it was hard.
I see Carlos is giving you the I agree.